Alright, in this video, I'm going to be working the problems from the Unit 11 practice test for college algebra. Okay, so the first thing I've got is something you might not have done in a while. It's composition of functions, right? If you haven't thought about this since spring break, you know, it's probably been a couple of weeks. So remember, with the composition of functions, what we're doing is we're going to, if we're looking for g of f of x, we're going to plug in f of x into g. So, you know, if g of x is, you square the thing, g of f of x is going to be, you're going to square f of x. So I'm going to say that this is f of x squared. And then I'm going to say that's x plus 4 squared. But I'm not going to say that's x squared plus 16, right? I know that I got a FOIL. So I'm going to say that's x plus 4 times x plus 4. And that's going to be x squared, 8x, and 16. All right, for f of x, okay, that one's a little weird. Okay, so what I'm going to do is I'm going to, wherever I see x in the formula for f, I'm going to plug in f of x. So this is going to be f of x plus 4. Yeah, that's just barely in the window. And I know what f of x is. F of x is x plus 4. So what I'm going to do is I'm just going to combine like terms. I'm going to say that that's x plus 8. All right. Now we're going to find some inverse functions. Okay. Haven't thought about this since before the break. It would have definitely been a while. Okay, so you're going to need to do a few of these. Remember that finding the inverse is basically just solving for x. Okay, so this is saying that y is equal to the x to the 7th, then subtract 7. And if I'm trying to solve for x, well, then what I'm going to do is I'm going to add 7 to both sides. And then to get x on its own, that will be the 7th root of y plus 7. Okay. But notice over here, they're asking for f inverse of x. Really what I've got here is f inverse, but of y. So I just need to replace y with x. So f inverse of x is equal to the 7th root of x plus 7. Okay. Over here, I've got y equals e to the x minus 8 power. And I know that if I want to get a variable or a thing down out of an exponent, I'm going to need to use a logarithm. So what I'm going to do is I'm going to take the natural log of both sides, base e log. So the natural log of y is going to equal the natural log of e to the x minus 8. And we know that the natural log of e to some power is just that power. You know, it's like saying, what exponent do I put on e to get e to the x minus 8? Well, I put the x minus 8 exponent on e to get e to the x minus 8. I hadn't thought about it like that. Okay, so then I'm close. I'm just going to add 8 to both sides. So 8 plus the log of y is equal to x. But again, I've got f inverse in terms of y. So I need to just replace y with x and call it f inverse of x equals 8 plus the natural log of y. And that's great. All right. This next one I've got here is y equals 1 over x minus 5. Now I feel like there's a couple of ways to do this. So I'm going to start doing it the way I would definitely approach it. Y equals 1 over x minus 5. Okay. If I'm trying to get x, I need it out of the denominator of the fraction. So I might just flip the fraction on the right and say this is, well, this is y over 1. And, you know, if those two fractions are equal, then they'll be equal if I flip them. So I've got basically 1 over y equals x minus 5 divided by 1. That's legal. And then what I'm going to do is I'm going to add 5 to both sides. And I'm going to switch it to f inverse of x equals 1 over x plus 5. But, you know, maybe you're not comfortable with that operation, right? You're like, oh, I'm not sure that works. Okay, what you could do instead is say y equals 1 over x minus 5, and then multiply both sides by x minus 5. So x minus 5 multiplied by y is equal to 1. And then you could, I mean, if I want to get x by itself, I'm going to have to divide by y, get rid of that y. So I've got x minus 5 equals 1 over y. And notice that these are the same thing. At that point in the work in black, I'm I've got 1 over y equals x minus 5. In red, I've got x minus 5 equals 1 over y. They'll work out the same way. Okay, if 3, 5 is a point on the graph of y equals f of x, then what point must be on the graph of y equals f inverse of x? Okay, well, what we know here is that f of 3 equals 5. Now, I'm going to just tell you it's going to be 5, 3. But what I could say is that, if I'm interested in f inverse of 5, that's solving for x, where f of x equals 5. And that's x equals 3. So you'd say that f inverse of 5 equals 3. Meaning that the point 5, 3 must also be on the graph of y equals f inverse. Okay, what if they gave you a picture of a graph and said find f of 2? Well, what you would have to do is you would have to start with f of 2, start with the inside, and then work your way out. F of 2 is I go over here to x equals 2, go up to, it looks like y equals 3. So this is f of 3. And then I will say f of 3 is, right here, that's looking like 0. So, f of 2 is the same as f of 3, which is 0. Okay, geometric sequence. First 3 terms of a geometric sequence are 9, 12.6, and 17.64. Write an explicit formula for the nth term of the sequence. Okay, well they said it's geometric, which means that there is a constant ratio between the terms. So if I divide 17.64 by 12.6, and if I divide 12.6 by 9, I should get the same thing. Okay, so I'm going to do that. I'm going to grab a calculator. Okay, there it is. And so like I was saying, I'm going to take 17.64, and I'm going to divide it by 12.6. That's 1.4. And then I'm going to take 12.6, and I'm going to divide it by 9, and that's going to be 1.4. So that means that each time I'm multiplying by 1.4. So what I'm going to do is I'm going to just get rid of this calculator. And I'm going to say, well, I know how to write an explicit formula for the nth term of a geometric sequence. Okay. In general, the nth term of a geometric sequence is equal to the first term multiplied by r to the n minus first power. Well, I've got r equals 1.4. And I've got the first term equals 9. So really, it's looking to me like this is going to be 9 times 1.4 to the n minus 1. And that's an explicit formula. All right. Now we got a domain question. This one's kind of weird. This is kind of like one of the questions that I saw when I went and sat and took the CLEP last year. Okay. It said, which of the following are in the domain of f of x equals the square root of 5 minus x divided by x minus 3? And I think it might have been one of those, there's kind of some weird questions on the CLEP. It might have been like check all that apply or something like that. And so let's just kind of look at these one at a time. So let's look at x equals 5. Okay, well, x equals 5, okay, f of 5 would be equal to the square root of 5 minus 5 is the square root of 0 divided by 5 minus 3 is 2. That's equal to 0. And if you're unsure about the square root of 0, is that allowed? Is that not allowed? Okay, you could think, well, if I square 0, do I get 0? Yeah, yes, it's true. And you could also grab the calculator and type in the square root of 0 and see if it kicked you back an error. If it kicked you back an error, that's a problem. If it tells you it's equal to 0, which is what it's going to do, then you know you're fine. Okay, so yes, that thing is in the domain. There's nothing wrong. Nothing bad happened. Okay, x equals 10. Let's see what happens when we put in 10. Okay, 5 minus 10 is negative 5. Divide by 10 minus 3 is 7. The square root of negative 5 is not a real number. Okay, and in this class, we only deal with functions that take in a real number and give you back a real number. So this is not in the domain. X equals 3. Okay, well, let's look at f of 3, see what happens. 5 minus 3 is 2, and 3 minus 3 is 0 divided by 0. I know that's not allowed. That is not going to be in the domain. Okay. And if you're unsure, you could just type in the square root of 2 divided by 0 into your calculator, and it would say error divide by 0. Like, why are you trying to get me to divide by 0? It knows you can't do that. You should know that as well. Okay, so the last one I've got over here is x equals negative 3. So f of negative 3 is equal to 5 minus negative 3 is 8. Square root of 8 divided by negative 6. And that's a real number. It's some kind of weird number, but it is a real number. So there you go. That is, in fact, in the domain. So that's how you do a problem like that. You're just going to take it one at a time and make sure that you're not dividing by 0, taking the square root of a negative number, maybe taking the log of a number that isn't positive, something like that. Okay. And here's another one that's very similar to a question that I saw in the CLEP that I took. The first and third terms of an arithmetic sequence are 5 and 21 respectively. Okay. Meaning that 5 is the first term and 21 is the third term. Find the 14th term of the sequence. All right, well, what I'm going to do is I'm going to just kind of set up and try to figure out a little bit more about this sequence. So 5, then there's a second term, and then there's 21. And I know that with an arithmetic sequence, you add the same number every time. So I added D, and then I added D again. Okay, now if I want to find out what D is, I've got 5 plus D equals 21. So that's going to be, I'm going to subtract 5 and combine like terms. So that's 2D equals 16, meaning D is 8. So if I take 5 and I add 8, that would give me 13. And I take 13 and I add 8, and I get 21. Okay, so I figured it out. Okay, now it might be helpful for me to write an explicit formula for the nth term of the sequence. Okay, now I know that in general, the formula for an arithmetic sequence is the nth term is given by the first term plus the difference times n minus 1. So in our case, the nth term is going to be 5 plus 8 times n minus 1. So if I wanted the 14th term, I'm just going to plug in 14 for n. Right? And, well, I'm not sure. I don't know my times tables for 13. So at the 8 times 13 is going to be 80, plus 24 is 104, plus 5 is 109. All right, and here I've got a bunch of problems that are all going to relate to this same thing, where I've got a graph, I've got a table, and I've got an equation. Okay, f of x is the table, g is the graph, and h is log with base 2 in argument x. Okay, so f of 1 is going to be, okay, you go into the table, okay, x is equal to 1, right? Y equals f of x. So plugged in 1 for x, and I see it here, and I go down, and that's equal to 4. G of 1 is, well, the height of the graph at x equals 1. It's like, oh, of course you chose the place where it's split. Okay, I know it's this one because that's where the filled in circle is. So that's going to be 2. H of 1 is the log with base 2 in argument 1. Now, if you needed to use a calculator, you could say, you could use the change of base formula and say that's natural log of 1 divided by natural log of 2. I'd prefer that you just know what this is, though. You're saying 2 to what power equals 1? What exponent do I put on 2 to get 1? You put the 0 exponent on 2 to get 1. And that's true for, you know, any base log with argument 1. It's going to be 0. So that's 0. All right. Let's evaluate some inverses. Okay, so f inverse of 2. Now remember, you see f inverse of 2, this is where you're saying f of x is equal to 2. Okay, this will be where g of x is equal to 2. And this is where h of x is equal to 2. So like earlier when I said you're solving for x, you're finding the x values, you're mapping back into the domain. Okay, so f of x equals 2. Let's look in the table. Okay, here's f of x. That's where f of x is equal to 2. So I've got it. I go back up. What x is it? It's 4. So this is equal to 4. Okay, g of x equals 2. Well, you go over here to the graph, and that's g of x equaling 2, and you kind of scan to the side. I don't see anything there. There it is. This is it. So I trace back to what x that had, and that's x equals 1. Okay. H of x is that's an equation, so I'm going to need to just kind of set up for some algebra. So I've got log base 2 of x is equal to 2. All right, and so there's, you could take 2 to both sides powers, I think what I would expect you would do. And so I would get x equals 2 to the 2, and so this is equal to 2 to the 2, which is 4. And that's us evaluating inverses. All right, now let's do some composition functions. I'm going to start with the inside. I'm going to figure out what f of 1 is. Okay, f of 1 is looking like 4. Okay, so now this is equal to f of 4, which is looking like 2. Okay. G of 2, so I'm going to go over here to x equals 2, find that's negative 2. Okay, so this is equal to g of negative 2, which is looking like negative 1. And then h of 1. Okay, well, I think earlier I found that h of 1 was 0. I showed you why that was true in, I believe, number 13. Yes. And so what I'm going to say is that this is h of 0. Now, h of 0 is the log with base 2 and argument 0. Now, again, you could go to the calculator if you really felt like that was necessary. Or you could say that this is 2 to what exponent is equal to 0. And I'm going to say that that's not possible. You can't take 2 to any power and get 0. You take it to a positive power, it's going to be positive. You take it to a negative power, it's going to be positive but small. You take it to the 0 power, it's going to be 1. Nowhere in there is 2 to any power going to equal 0. So what I'm going to say is that this is undefined. All right, and then the last three I've got for you on this composition of functions thing is going to be, okay, f of g of negative 1. Let's start with g of negative 1. G is the graph. G of negative 1 is 0. So this is equal to f of 0, which if you go to the table, that's looking like it's 1 right there. Okay, g of f of 4. Okay, well, what I can do there is I'm going to go to f of 4, and that's 2. So that's g of 2. And you go over here to g of 2, and that's negative 2. And then f of h of 16. I'll do this h of 16 work over here to the side. This is log base 2 of 16. So you think, what exponent do I put on 2 to get 16? I put the 4 exponent on 2 to get 16. Okay? So that's equal to 4. And then this is f of 4. And then again, f of 4, right, is equal to 2. Okay, see, I've already marked on that. So there you go. And that's kind of the type of questions you can expect with graphs and tables and equations and stuff, with the compositions, the inverses, things like that. And there's going to be quite a few opportunities for that on the test. All right. So sketch the graph of y equals x plus 2 when x is less than negative 1, and negative 1 when x is greater than or equal to negative 1. So I'm going to need some graph paper or something like that. All right, there we go. I've got myself some graph paper, and I'm going to give myself some axes. Here's y-axis. We shouldn't change too much, especially in the positive direction. So maybe I'll put the x-axis right here. And that'll certainly be good enough. And so what I'm going to do is I'm going to actually graph this part in red, and I'll graph this other part in blue. So I'll start with y equals x plus 2. Well, y equals x plus 2 in general looks like that line, right? Except this is only valid when x is less than negative 1. So what I'm going to do is I'm going to get rid of that. I'm only going to start at x equals negative 1. Plug in negative 1 for x and see what it would be if it was equal to negative 1. And that would be positive 1. So negative 1, positive 1. Okay, I'm going to leave an open circle there because x is strictly less than negative 1. And I know that it's got slope 1, so, I'll kind of just draw in like that. And since it's all x less than negative 1, I'll put a little arrow there. Okay. For y equals negative 1, okay, well, y equals negative 1 right here. Okay, and y equals negative 1 for all x that are greater than or equal to negative 1. And then I'm going to just, draw in an arrow like that, nice flat lines, like that. And that is a decent sketch, especially if, of course, label our axes, like that. That's good. All right. Now here's one. Write an equation for the graph pictured below. Now, this is a little tougher, right? And even sketching the graph is a little harder than you're going to be expected to do on the test. This question lends itself really well to multiple choice, right? And it's like you've got four equations to choose from. Or on the previous one, you've got 4 graphs to choose from. Something like that. So that's what I would expect if I was y'all. Okay. So really the idea is I know that it's going to be y equals, and there's 2 kind of branches of graph. So I'm going to, set up a little bracket there. And, well, maybe I'll color this one in blue. And this one in red, just to make it clear what I'm doing. All right. Now what I'm going to do is I'm going to actually start off with a domain, with that stuff on the right. So blue seems to only apply when x is less than negative 1. And then the red seems to apply when x is greater than or equal to negative 1. And then now I just need a formula for each of these types of graph. Okay, the blue one has this is flat line, so it's going to be y equals some number, and it seems like they all have y coordinate 4. So y is just going to equal 4. And then for the red line, okay, this has got mx plus b, right? Slope and intercept. Mx plus b. Okay, well, the slope is negative 1, I can see. So I'm going to get rid of the m and replace it with a negative 1. And b is positive 1. That's a y-intercept. So it's negative x plus 1. You could also write this as 1 minus x if that was how you felt, but, no need to. Because, when it comes time for the test, you're just going to be recognizing the right answer anyway. Right? Here we've got 2 domain questions. And remember that in terms of these domain questions, kind of like the domain question we were working on earlier, things we're not allowed to do is divide by 0 and take the square root of a negative number. Okay? So for f of x, I need to just make sure that this thing I'm highlighting, yeah, I need to make sure that's not 0. Okay? So as long as 4x plus 3 is not equal to 0, I'll be good. Okay, so what I'm going to do is I'm going to say 4x is not equal to negative 3, and x is not equal to negative 3/4. As long as x is not equal to negative 3/4, I won't be dividing by 0, and I'll be good to go. So this is my domain of f. Now for g, I need to make sure that this thing that I'm highlighting is not negative. And not negative means greater than or equal to 0. So I'm going to say that this 2x plus 12 needs to be greater than or equal to 0. And so what I'll do is I'll just kind of try to solve for x the old way, the way we've been doing the whole time. I'm going to start by subtracting 12. 2x is greater than or equal to negative 12. and x is going to be greater than or equal to negative 6. What happened to my handwriting there? That's pretty rough looking. Okay, but that would be the domain of G. This is looking like, looks to me like it's going to be, oh, yeah, I even forgot to change that. It says let B be the arithmetic sequence. B is given by 10, 15, 20, 25, I would assume 30, 35, 40. Here we go, and we look at this, and we see it's plus 5, plus 5, plus 5 every time. Okay, dot, dot, dot indicates the pattern is going to continue. So this is an arithmetic sequence. Okay, so I've got an arithmetic sequence with first term 10 and common difference equals 5. So, okay, remember that the nth term of an arithmetic sequence is given by the first term plus the difference times n minus 1. So, internal Bn is going to be, first term is 10 plus 5 times n minus 1. And the value of the indicated sum. Well, they're asking me to add up the first 101 terms. Right, so this is 10 plus 5 times n minus 1. These are the things we're adding together. And what I'm going to do is I'm going to start to write out a few of these terms. So that's 10 plus 15 plus, all the way up to the 100th term would be 5 times 99 would just be just a little less than 500, I guess. 495 plus 10 is 505. And then I plug in 100, kind of into this formula right there, or 101 into that formula, and I'll have 500 plus 10. Okay, so plus 510. Okay, so you remember when I did this in the lesson, and we did this, we did practice problems, we did it on the quiz. What you do is you kind of pair them up. Okay, that's looking like 520. This, also 520. So what it's going to be is it's going to be 520 times the number of pairs. Well, if I'm going from 1 to 101, start counting on your hand. I guess you can't see me counting on my hand, so I'll just make some tally marks or something. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 95, 96, 97, 98, 99, 100, 101. Okay, there's 101 terms, basically, is what I'm saying. So there won't be exactly 101 pairs, but remember we can still do 101 divided by 2. The formula still works when there's an odd number of things you're adding together. So this is 520 times 101 divided by 2. That seems like a job for the calculator, so I'm going to go in here and I'm going to just kind of put it all up. So it's looking like 26,260. Definitely a job for the calculator. All right, now the last problems I've got for you are looks like geometric sequence questions. Okay, so what I'm going to do is I'm going to kind of do some analysis on this sequence, make sure it's geometric. When I go from 1250 to 250, not sure. When I see 250 to 50, that's divided by 5. So that's times 1/5. And then 50 to 10, also times 1/5. And 10 to 2, 1/5. Right, so really all that remains to be seen is that, what is 1/5 of 1250? So I'll go in here on the calculator, 0.2 times 1250. Sure enough, it's 250. So it's times 1/5. So this is a geometric sequence with r equals 1/5. And write an explicit formula for Cn. Okay, for a geometric sequence, the nth term is equal to the first term times r to the n minus first power. Okay, well, the first term is 1,250. So for us, Cn will be 1,250 times 1/5 to the n minus 1. And then if we want the infinite sum, okay, I need to check that the ratio is less than 1 in absolute value, which it is. Now, honestly, in this course, I'm probably not going to ask you to take an infinite sum that doesn't exist. Because the idea of convergence and divergence and stuff like that is really more suited to a calculus class. Okay, but this formula is really easy to remember. Remember, it's first term multiplied by 1 over 1 minus r. Okay, so that is, the first term is 1,250 times 1 over 1 minus 1/5. Now, my recommendation for this is that you bring in the calculator. So, here I am. Oh, there it is. Okay, so that's 1250 multiplied by, I need that fraction bar, not sure how you get that, 1 over 1 minus 1/5. 1/5 is 1. Type it in just like you see it. 1,562.5. Okay, sure enough. And, you might be thinking, wait a second, I'm just adding up whole numbers. But you're really not. You see over here, 2 is the last one you see, but each time you multiply by 1/5. So the one after that will be 0.4. Okay, so it's not surprising that your answer would have a decimal in it. Now, I'll kind of just copy that down, but that's going to be all I've got for you on this practice test. 1562.5. If you are having any trouble with the problems on the practice test, or you don't understand my solution to some of them, you need to come see me in the morning. That's my best recommendation. Come see me, come see Mr. Messner, come get your questions answered before you take the test. And if you do understand what I was doing in this video, then you will do just fine on the